Okay, like I said, thanks everyone for joining us today on our webinar. I think it's probably maybe the 10th one we've had since Enova merged September 2022. So we're trying to roll these out on a quarterly, maybe even a monthly basis, trying to bring different vendors or presenters in to speak on different topics that you guys want to hear. So if there's anything that comes to mind that you want to hear about, by all means, let us know, and we'll definitely see if we can set something up for the next one. With that, today's agenda is first we're going to give a quick update from Chris and I about what's new from Enova. Then we'll dig into Steve's presentation on the 7 steps and finish off with a Q&A. But if you have any questions along the way, feel free to put them in the chat. Feel free to raise your hand, and we can unmute you. You can ask your questions. So let's just make it kind of a little bit of a workshop here, and we'll learn together. Anyway, so what's new from Enova real quick? Ontario's energy and water reporting benchmarking is coming up. It's due July 1st for all buildings that are 50,000 square or larger. You got to report on electricity, gas, and water usage. And if you need some electricity data from us for your reporting, the website there, you can go ahead and submit that. I know we say it might take 6 weeks and get your request in before the 15th of May, but we're pretty quick at turning these over. They're not really hard to do. Second of all, this is kind of asked of our communications group that we're running our annual elementary school electrical safety art contest. It's pretty cool. You just have to submit a piece of artwork or a video, a song, a poem, some sort of art to that website there. And you could win a $50 gift card and a Enova prize pack, as well as having it kind of featured on social media and in our communications. I think I heard there's only maybe a handful of entries so far. So if you got a kid that's interested in that, they've got a good chance of coming away as a winner.
Andrew,
And then
is there an age limit to that, or?
It's grades 1 to 6, so it's elementary school.
Okay.
Yeah. Thanks, Chris. And then, as mentioned before, we're always looking to present on interesting topics for webinars coming up. May 29th, we're going to have a presenter from Carbone. They're kind of administering the market that's coming to the Ontario through the ISO on clean energy credits. And then, abutting that, I guess another relevant topic is talking about the clean technology investment tax credits that are that were announced back in the fall budget, but are actually coming through and should take effect in June. So kind of timely for that one as well. All right, so you may know us, Chris and I, we are your key account advisors. And we're here to help you with your business and whatever issues you may have. And you might have heard from this spiel from us over and over again. So we thought we'd try something a little bit different today, just the way that the world's headed. And we wanted to ask ChatGPT how we can help. So take this with a grain of salt. I kind of just extracted kind of the main points here. I'm not going to go over it verbatim, but feel free to put this prompt into ChatGPT yourself and see what it comes up with. But I asked, what are the 7 ways, in line with Steve's 7 steps, ways that Enova Key Accounts team can help you. So dedicated support, where you're set a single point of contact here at the utility. We can help you with your strategic planning, help you set realistic goals for cost savings and sustainability. Customized solutions, that's kind of a weird one, but nevertheless, we can provide expert guidance, right? Help you with renewable energy options and whatnot. Market insights, we try to stay ahead of the curve and know what's coming. The market in Ontario is ever changing, especially with our capacity constraints and the amount of embedded generations coming online. So we're trying to kind of bring this information or provide this information to you when it comes available. Risk management, I guess this was kind of an odd one, but the way I can think of it is, Class A versus Class B. That time of year is coming around again, where you're trying to, determine, is it better to opt in or opt out? And we'll do that kind of analysis for you to say, based on the previous reporting period, it might be beneficial for you to go one way or the other. So we'll help you with that. performance monitoring. We have M&V, data logging equipment to help you with M&V. We can do analysis on your load profile, your consumption profile, and find ways or areas that, maybe if you just shifted your loads, a few minutes or a few hours, that you could benefit from that as well. And sustainability, I think we all kind of have this top of mind. What is sustainability and what do we do with it? And we're here again to offer you some information, like our upcoming webinar on carbon credits. Mind you, that's probably the last thing I want to do. Nevertheless, we're here to help you work through your sustainability initiatives. So yeah, that was a fun activity with ChatGPT. So check it out, and like I said, that's that prompt that I use. So feel free to explore. And with that, I think we're off to our presentation. Take it away, Steve.
Great. Thanks very much, Andrew and Chris, for the opportunity to come and share today with you some new, well, not new ideas necessarily, but maybe updated and refreshed ideas. Some of you may have seen this presentation before or a version of it, but we're always evolving it, and I'm going to add a few stories in about stuff we've been doing recently. So, and I like those cameras on. It's always good to have at least know somebody's out there on a camera. So that's great. Thank you, Mary, for that. That's wonderful. So yeah, it's going to be a little quick tour, 7 steps. It's kind of reflects what I've done over the last 42, 43, 44 years of energy management experience. So I'm going to start out with some big picture stuff. I think it's good for context. And then I'll dive down and take us through these things called the 7 steps that really come back to understanding how a facility uses energy today, and then what you can do to reduce it in terms of the last 3 steps. And you'll see what that means when we get there. Somebody once said to me a little while ago, "Hey, Steve, that's the path to net zero." At least the last 3 steps are, and I'll explain that one as well. But yeah, I think that's probably a fair assessment. I'll also show you throughout this presentation how you can use the tool called Red Screen Expert. And for those that haven't heard of it, it's worth exploring if you're in the energy space. For those that have, you'll probably see things you've done before with it. I know there's a few people online that have used it. But for those that haven't got a copy or a license to it, I'm going to provide through Chris and Andrew a 14-day license for you to get out there and kick the tires with it too. You can download it and play with it. So that'll give you a chance to really explore some tools. And then I'll finish up looking at how we can apply these 7 steps in what it's called an energy hunt or an energy treasure hunt. We do these quite frequently. In fact, I did one last week or a couple of weeks ago, and doing one next week. They actually are really exciting interventions around energy. They can kind of combine training with auditing, with a little bit of existing building commissioning, and they really generate a lot of good ideas, a lot of collaboration, and identify a lot of opportunities. So from the big picture point of view, I always start with this slide because even though we're going to talk about technical things today, both operational and technological ways to save energy, I just want everybody to keep in mind that, and this is the same, Andrew, you were asking me about AI before, right? What did I think about AI? It's about balancing people and technology together. So the human aspect of this thing is going to be always important, right? So awareness and habits and procedures and the feedback that we get, even the numbers that we see, the feedback reporting and things like that. And ultimately, organizations do have to embrace this as an organizational function. That is a dollar sign at the center. So if we're successful, we will see, in most cases, a fiscal result, positive fiscal result. But that's also a black dollar sign, which to me signifies carbon. Hey, Paul, how you doing today? Long time no see. Great to see you out there. Yeah, so that's a black carbon dollar sign as well. So that is the outcome we can expect to achieve. And going forward, we will have to balance those 2 goals. Many of your organizations will have both financial but also carbon goals. And I think the ideas in this session will give you some perspective on how to balance that as well. Never compromise. In fact, I always say, show me your least reliable pump, and I'll find a way to improve its reliability and improve its efficiency. I know that if you go into a building and do things to improve the indoor environmental quality, comfort and productivity, safety, all those things, you actually will save energy as well. So saving energy and reducing carbon is not going to be at the cost of what we need energy for. No compromise. In fact, a good opportunity checks all these boxes. It'll actually positively impact all these different aspects, including both the direct and the indirect savings, which is really what we go after initially. But I think reliability, and indoor environmental quality can be positively impacted for sure as well. Again, like I said, there's a tool there that you can use. It's an all-in-one tool. If you haven't met it before, have a look at it. Even if without the license key that I will send out to you, you can download it, you can play with it, get a sense of what it's all about. So this PowerPoint will be sent out afterwards, and I'm pretty sure all those links are actually going to be active. So what are the 7 steps? The 7 steps are comprised of 2 phases, or two pieces. The first part of it is basically 4 steps that help you to understand how a facility uses energy today. And the second part are 3 steps which allow you to find opportunities and organize those opportunities or measures in the correct order from a technical and a financial standpoint. So taking it from the top, I always, and this is an audit methodology. Years and years and years ago, in 1990, somebody said, I was doing a webinar, a seminar back then. We didn't have webinars, like seminar back then. And somebody said to me, Steve, you're talking all about these energy audits you can do. It seems to me you could help us to do energy audits ourselves. And I said, yeah, I could do that. And my boss was in the room. He didn't like it, but I said, yeah, we could create a training session for that, teach how to do an audit. He didn't want to do that, but his friend worked for the federal government, and he said, yeah, we can help you to do that too. So anyway, that actually eventually evolved into the dollars to cents workshops from Natural Resources Canada. But at the core of all that was essentially this methodology for doing a self-assessment audit. And those workshops still are available today here in Ontario. And there's actually between a 50 and a 75% subsidy available to them. And if you're interested in those, Chris and Andrew can point you in the right direction to accessing that subsidy. So first step, understand your consumption, price, and cost, right? And there's some surprises when you do this. Second step, benchmark yourself. Compare yourself to others, which is how we traditionally think about benchmarking. I like to compare myself to myself, or a building to itself. Understand when your building uses energy, really, really important. So Andrew and Chris, you may get some requests for some data after this workshop as a result of that step. And where is it all going, right? Understanding where it's used, because that's going to help to prioritize your search for opportunities. Now, I guarantee you, if you walk through this and just apply this to a building that you're involved with, those first 4 steps will uncover opportunities. Now you have to prioritize, organize, and find more opportunities. Waste, energy we don't need to use. Efficiency, how well we convert the purchase form to the end use form, right? And that can be both operational and technological. A filter is operational, a new boiler, a new chiller, that's technological. And then the supply side of things. Where are we going to get the energy from that we need, right? And one could argue that heat pumps kind of fit somewhere between 6 and 7, but they're definitely in those last 2 steps. The application of things like heat pumps and renewables and heat recovery and all that stuff that basically substitutes new supply for old supply. So that's the 7 steps. Let's take a quick tour through these. And I'm going to kind of give an example in each one. Here's our financial person in an organization that was studying the bills and couldn't understand why his costs were up by 3.6% when he only used like 1/100% more energy. But what this person didn't understand about the bill is that you don't just pay for how much energy you use, right, which is the area under your demand profile, but you also pay for how fast you use that energy, right? And so basically the 2 determinants of the bill are the energy and your peak demand, measured on typically a 15-minute basis for Enova, but then on a provincial level measured on an hourly basis. So demand always has a time period attached to it. And we all know that we pay, depending on the rate that we're on, we pay a different price for each and every hour, whether it be at home with the time of use rate, or whether it be the hourly Ontario energy price in commercial, institutional, industrial buildings. So the problem with the bills that this gentleman was looking at was that he didn't realize that he pushed 60 kilowatts up on peak in that second month. So January was the blue, February is what we added, right? The 60 kilowatts for 15 minutes at 10 cents a kilowatt hour, that's $1.50. But to get that power to them, to get that 60 kilowatts there, that additional 60 kilowatts of demand at $11 a kilowatt, which is about what it is within an Enova rate, is about $660. So some things we do are heavily weighted towards this demand, or we otherwise know as delivery. So we can break down the bill, and I always like to look at that. So when we do an energy hunt, when we work with folks, we look at this and we find opportunities by really understanding, how that bill breaks down, depending on the type of customer, your usage patterns. You may have more or less of the bill on the demand versus the energy side. A lot of people focus on the energy, but there's still opportunities out there on the demand side. I'll share some of those with you, right? Certainly, there's lots to understand about the hourly price, and maybe there's opportunities to use that energy at a different time of day. Certainly understanding how you're using it today is going to be key. If you're a large customer, above 0.5 megawatts for an industrial customer or 1 megawatt for others, then you will actually have the opportunity, as you talked about a little bit earlier there, Andrew, to pay for your energy, or at least part of your energy, based on your contribution to 5 top peaks, or what is otherwise known as global adjustment class A. The key thing I like to take out of this is if you do all the math on it, and it can get a bit complicated. I'm not going to do that today. But I know that if I can remove 1 kilowatt of waste, right? So 1 kilowatt, right, times 8,760 hours, that's 8,760 kilowatt hours. At 10 cents a kilowatt hour, that's about $900 a year. But that 1 kilowatt will add, right, 300 kilowatts to what, or take away $300, right? Because you take a kilowatt off each of those 5 top peaks. That's lucrative, right? So, a lot of people try to shoot for that peak, but you can actually take it off the bottom as well. So again, knowing what you're paying for and what it's worth, right, is very important. So I always like, when we do a treasure hunt, when we sit with people and talk about where the opportunities are in their building, I always like to make sure I understand the prices that we use. So there's the prices. I've just taken a sample from one of Enova's rates, depending on where you are. They're a little bit different, and also put gas on the same basis. Because at the end of the day, we need to understand that relationship between gas and electricity. What do I mean by that? Well, take a fictitious building, but it could be one of your buildings. The energy it uses, the pie chart for the energy, if you take the gas and multiply it by 10.6 equivalent kilowatt hours per cubic meter of gas, compare that to electricity you consume, if that's 50-50, turns out that you're probably paying 85% of your cost for electricity, and about 75% of your carbon is attached to the natural gas. So if you have goals of carbon and cost reduction, then ultimately you've got to deal with both sides of the house, right? And you got to do those synonymously. But then also, we all know probably this idea of electrification, by shifting gas usage to electricity in some form or fashion. There's other things we can do, but if we do that, then that's going to change these pie charts as well. So those are good pie charts to begin with whenever we sort of enter into this endeavor. And the factors behind that are on the screen here. I'm not going to go into details, but there's simple factors that can be applied to gas and electricity. And if you use RETScreen, those factors get applied implicitly. So you don't have to do all the heavy lifting calculations. RETScreen is well equipped to be able to break that down for you: energy, costs, and carbon. Step 2, benchmarking, understanding how you compare. And many of right, under reporting requirements now in the province, the EWRB, you have to do this on an annual basis. And I think that's going to move down to very small buildings in the future. At the end of the day, that's just a good practice, understanding where a building stands. The first thing I do beyond looking at the bills for a building is to say, okay, how does this building compare to other buildings of similar type? And I also take a look at how the building compares to itself. What's interesting is you can do that a couple of ways. A little while ago, I'm going to show you how I use benchmarks. I got a call from an organization. They had a building. It's actually it was police enforcement building. And they called me up and said, hey, listen, we have this building. Is it worthwhile doing an energy audit? And I said, well, I haven't seen the building. It's not even in the same province I am. They said, well, okay, the building uses this much energy a year. I said, can you tell me how much its peak demand is? Anyway, make a long story short, I calculated the demand intensity, the watts per square meter, the electrical energy intensity, the kilowatt hours per square foot, kilowatt hours per square foot, and the gas, so natural gas heating energy intensity in kilowatt hours per square foot. Now, I could look at the overall intensity and say that's way above other buildings, which it is. But what I actually did was to say, how do those 3 indices, or how do those 3 intensities compare to one another? And very quickly, I was able to determine that even though the demand and the energy, or gas energy intensity, were kind of in the typical range, so I had 6.7 for demand, at 4 to 10 was the range, 16.9 for gas, 12 to 24 was the range. Then I looked at the electricity, 30.6, way above the range. So I started to ask a few questions, and it turned out they had an operations center on 1/4 of one floor for which they ran the entire HVAC system, right? So we estimated, I didn't even go near the building, we estimated that if they could bring that back into range, right, so bring the 30 down to a 20, that'd be about $65,000 years worth of savings. That justified them doing an energy audit. And the energy audit found exactly what I'd found from the benchmark. So benchmarks can be very insightful if used properly. Again, I would encourage you not just to use the overall intensity, which is kind of what you get with Portfolio Manager, but to dig down underneath and look at the different intensities. If anybody's interested, I have a spreadsheet that I can send you that'll do that. If you've got multiple buildings, it's actually a great way to stack and compare buildings. The other thing I like to do when I go to a building, and we were doing basically a simple energy assessment in this building, is to look at how the building evolved over time. So they provided me with about 5 years worth of data, and I actually did an analysis. The analysis is done with RETScreen. It's called the QSUM analysis. I build a statistical model of the building or its baseline, and then I look at the trajectory of the building beyond its baseline with a curve called the QSUM curve, the cumulative sum of difference between what we expect to occur in the baseline, that's the horizontal period, what actually occurs in the future. What was surprising to this building was that they'd avoided a ton of consumption through actions that they taken. They had no idea. They actually, I think, reduced the consumption in the building by about 37%. But the costs were going up, so they're just looking at the cost. They had no idea how successful they'd been in terms of their electricity consumption through different actions that they've taken, and their gas consumption as well. So this allows us, when we get to when we're doing the assessment over here on the right-hand side, now we know all the things that have contributed, right? And maybe some of the ones that haven't. There's a few places where there's some bends and turns in here which could be corrected. But at the end of the day, this curve gives me a very insightful picture of what's happened in that building historically, how it got to today, and then that helps me to understand what I can do taking that building into the future with less energy. So comparing a building to itself, I call that regression and QSUM analysis. And again, RETScreen has the tools for that, but also the tools for doing overall benchmarking if you have a portfolio of buildings as well. So a great tool for comparisons. When does a facility use energy? If you go to the doctor and say, hey, listen, I want to get a checkup, today, at my age, they're probably going to give me an EKG where they're going to put some leads on me and they're going to check out my heart. This is a 2-lead EKG for a building. This is actually the kilowatts, which is part of how you pay for your electricity, but also the power factor, which is a sort of an underlying characteristic of the power that you demand from the utility. This can tell me a lot about what a building's doing, right? So I can look at this and I can tell you that the lights in this building don't go off until 8 o'clock at night, because I know that lights have a higher power factor, therefore they contributed to this higher. And when it drops, that's when the lights are going off. So these profiles are really, really insightful. Even without the power factor information, and maybe not even electricity, we're starting to gather data for buildings, hourly gas data. This building had 4 boilers that were all basically the same size. They were supposed to be sequenced and controlled, but what we discovered was there was times where all 4 boilers were slamming on and off. Now, if you're a building operations folks like Paul, you don't understand the problem with this situation. It's not only an energy problem, but that's a maintenance. That's going to affect the reliability of those boilers. In the latter part of the year, they were able to get things under control. You can see more staging of those boilers, 1, 2, 3, and maybe not even 4 boilers, right? But here we've got in June, 4 boilers, all on, all off, maybe 3 boilers on and off. That's a big problem. It was funny because the folks in the building kind of were aware that the boilers were not functioning as they should, but they didn't really understand the magnitude of the problem. By looking at the hourly gas data, we're able to figure that out pretty quickly. And then we looked at the electricity data. That's a lot more pattern because electricity use depends on the schedules in the building and weekends and weekdays and things like that. When it gets really interesting is when we give this kind of data to building operators in these energy treasure hunts. We bring people together. We bring a number of operators, maybe from different buildings. We provide them with profiles for their buildings. And then they start having a conversation over break. And one operator says to the other one, well, why is mine a lot higher than yours? And they actually knew each other's buildings pretty well, and eventually discovered that there were overrides in the automation system that were causing one building to consume significantly more energy than the other one, to the tune of $20,000. So one conversation over coffee break in an energy hunt, and this $20,000 worth of opportunities identified, right? Very, very impactful endeavors. Here's another situation, an energy treasure hunt. We've produced this graph. And if you look at this graph, you'll realize that we've got temperature here. This is temperature, the dotted line. And here's the electrical demand on a 15-minute basis in this building. There's a couple of issues here. One is something is cycling a lot at night. Turns out that the chillers had problems with controls. They were cycling too heavily. But the interesting one was this peak at the end of the afternoon. This is the time when in this building in the summer, they would actually set the temperatures up. They would go from, say, 22 to 26 as a set point, allow the temperatures to rise up gently over the evenings. Well, the controls didn't want to let it rise gently. The controls wanted to raise the temperature to the set point. So now all of a sudden the electric heat in the building, which it had, kicked in to drive the temperature up to the set point, created a huge peak demand. And now you got the heating and the cooling systems fighting each other in the cooling season, right? But we spotted that like within 15 minutes of getting the data and looking at it. That actually led them to do an existing building commissioning and then eventually to apply AI in that building to prevent that kind of thing from happening in the future, right? So these profiles are really insightful. RedScreen has all the tools to be able to do that. I've just shown you taking sort of columns of numbers and going to this weekly graph, like this previous one here. But there's also a thing called a heat map, which allows you to basically see 1 year in one glimpse, and you can start to spot patterns and trends and different things. Like you would ask yourself, what's going on this Saturday? It's funny, I did this recently in an office building, and somebody said, that's tax season. That probably is tax season in this building, right? Because then they operate more hours on a Saturday to about this time of year to get ready for taxes. So the accounting firms in the building. All right, where is all the energy going? I wish there was a meter I could clip onto a building and get a pie chart like that. Unfortunately, back in the day, we used to do this the hard way. You walk through a building and we make lots of notes and then eventually put it into a spreadsheet and create an inventory or breakdown of where the consumption is going. And we've done that in hundreds of buildings. Actually, if you're in municipal buildings, you can see some of these. There's about 42 prototypical breakdowns of different kinds of municipal buildings right across the province that we did a number of years ago. But basically, well, maybe there is a meter I can put on. Maybe I don't have to walk through the building. We were doing an energy hunt on a building. It was interesting. This was a pretty large office building with some retail space in it. And they had sub-meters all over this building. You can see all the sub-meters here. And what was interesting is they were using those sub-meters to allocate costs to tenants. But nobody had plotted the sub-meters on a graph like this where you could start to see what was going on. And make a long story short, what we discovered was in here, there's in-suite plug load, which is this yellow line. Things hardly never got turned off. We could see the waste of energy, right? So we could also see in the fitness center just how much energy was being used, or sorry, not the fitness center, for the cooling towers, right? Throughout December. So very interesting information when you start to pull us. Like, maybe you don't need to install new meters. Ask some questions. Do we have those meters out there? And use the data to the fullest extent possible. All right. Breaking down energy. Yeah, so back in the day when I used to do it with a spreadsheet, today I wouldn't do that. I would go through and I would use RedScreen. I can build a model of a building in RedScreen. In fact, if you want to kick the tires in that tool, if you haven't done it before, when you load it up, use a thing called the Virtual Energy Analyzer. It's right on the front page. You can go in and pick the kind of building you have, and it'll bring up a sample building, or what we call an archetypical building, and you can kind of see how it all flows, not just what's in there today, but also what could be done to improve that building. What are the opportunities in that type of building, and how might the financials work for that? So there's literally hundreds of those archetypes in RedScreen. That really leads us to the last 3 steps. And this is the one where somebody said, hey, Steve, that's the path to net zero. It's funny. I got a call from an organization the other day, and it was actually a private school, and they have a goal, I think, of reducing their carbon by 30% in 5 years, or 25% in 5 years. And they said, do you think we can do it? And I said, well, I don't really know much about your building, but we'll take a look. So we went over, had a meeting with them. We convinced them to allow us to do an existing building commissioning. And it was a pretty lucrative exercise because it basically paid for itself when you combine the incentives that are available from both the Save on Energy on the electricity side, but also Enbridge Gas on the gas side. But what was interesting is we found about a 30% reduction in carbon. So today when people say, can I get 30% or 20% in 5 years? I say, I might be able to give it to you tomorrow. and many of the energy hunts that we've been doing recently actually have shown those types of results, between a 20 and a 30% carbon reduction. And a lot of times the energy hunts go after operational means, right? Operational measures. So those are not things we have to spend money on. I'm going to argue that that's a good thing to do, but that's the foundation, right? That's the foundation for really moving towards lower carbon. There's no use in trying to change and modify and retrofit all your systems if the systems you have today aren't working as they should. So getting things into control, getting house in order first is the first step, and it will deliver you some handsome, some pretty respectable results early on in the process. So let's take a look at the last 3 steps. Waste. Waste begins with understanding what your real need is, right? How much heating or cooling, air power, fluid flow. What do you need? What do you need, right? Now, there's a formal way to define that need. It's called a current facility requirement. When you go into an existing building commissioning, where you take a building that maybe was once commissioned but it's now used for a different purpose or has evolved over time, you define what the current facility requirements are. You write them down and you agree upon those things, right? So there's no negotiating. And these are things that then guide the process of, well, in my world, getting rid of waste, but then recommissioning that building. And this, to a large extent, comes down to things like turning things off or technically scheduling things, turning things down, making sure temperatures are appropriate, water, airflow, and so on, and properly controlling things, using those automation systems properly. And as I said before, the formal term for a lot of these things is the existing building commissioning, which is a systematic approach to operational savings. I mean, you might find some capital measures like the installation of a variable speed drive or something like that in existing building commission, but largely it's going to be operational. And when you think about waste, my question right now is, what uses more energy? Your clock displaying time on your microwave, or cooking food in that microwave oven? Well, as my son would say, if you ask the question, Dad, it's probably the less obvious answer, and that is time. So on my microwave, which uses 14 watts to display time, I would have to cook food in my microwave 20 minutes a day, every day of the year, right, in order to use as much energy cooking food as that 14 watts is for 87 or 60 hours. You can do the math on that one if you want, but that's the reality. So a small amount of power all the time is a significant amount of energy compared to that large amount for a short period of time. Hey, Jason, you got your camera on. Did you have a question?
Nope, okay. I just sat down in my office. So
okay, cool. Welcome. All right. So what can we find in our energy hunts or energy treasure hunts? Well, we're walking through a mechanical room. One operator came up to me, he said, Steve, we got 2 pumps over here, heating water circulator pumps. I said, that's great. You got drives on them. He said, yeah, well, you got the drives on them. I said, like, is that a duty and a backup pump? He said, yeah. He said, I was wondering, why are we running both of them? I said, well, that's a good question. Why are you running both of them? We dug down a little bit. There was a deep override that was turned on during the commissioning at some point in the past, maybe 3 or 4 years ago, and never taken off. That pump was running on that. The second pump was running at 20% all the time, right? The drive actually gave us the data we needed to calculate the savings. That was so beautiful, right? This piece of technology displaying how much the waste is worth, about $2,900 a year just for resetting that override, right? So these are the kinds of things we find all the time. I went in one building we went into a little while ago. We were a little concerned, the colleague and I, Michelle, and another chap I work with, Ian, and they're both recommissioning specialists, but we were a little concerned because they gave us a building that had an Energy Star rating of 94. I'm going, holy mackerel, how are we going to find savings in this building? Well, we found 20%. We found 20%. They didn't believe us to begin with. So then they hired another firm to come in and recommissioning the building. They confirmed all that we found and then added to that list, right? So you got to start pulling away at the skin of the onion here and dig down underneath. And it's surprising what you'll find. And here's a very simple one, very visual, right? You got these great sensors that can harvest daylight. They can turn off your lights, dim them down when there's enough ambient light. But if they're located in the wrong place, over dark floor tiles too far from the windows, they're not going to do their job. So relocating one of these beautiful sensors, $400 a year in savings, right? So you bought the technology, but are you using it? Maybe not. Again, that's where existing building commission comes in. The more complex a building is, we find, like LEED Gold buildings are our favorite because they have so many things that can go wrong, right? If you've got heat recovery in a building, there's great potential in that building. Why? Because how many times do we find heat recovery systems not operating properly, right? They have potential to save a lot of energy, but because they're a bit more complex, they tend not to always work. So that's kind of, to me, the indicator of opportunity. Again, I've talked a lot about existing building commissioning, so I thought I would leave you with a reference for it. I like to describe it as taking what you have and making it better from the energy point of view, right? And it has 4 steps, and it's quite nicely documented, but there's also a series of webinars and such that are available from the ISO's website. I'll give you a link a little bit later on in this one, but lots of resources out there and lots of incentives out there as well. Again, a lot of the times the calculations we're doing under waste is about time and temperature. Now, I know there's some industrial people on the line, and sort of my presentation here is being a bit more about buildings. Don't get me wrong. there's lots of opportunities. We do treasure hunts in industrial facilities, and there's a lot more discretionary energy use in many industrial facilities. So the level of opportunity, I think, is equal to, maybe even greater than in a lot of commercial buildings. Maximizing efficiency, step 6. And I'm going to break this into 2 phases, operational and technological. And many times we jump to the technological, right? I want to put a new boiler in, I want to put a new chiller in, I want to put a new lighting system in. But do we really think about how we're operating what we have and how we're maintaining it, right? I mean, how many times do we go out and we look in a mechanical room, and here we see a circulating pump with what we call a triple duty valve, throttling it, right? Which means it's trimming the flow. Well, it turns out in this case, they had a variable speed drive available and powering this pump, but it was running at full speed. Ironically, a variable frequency or variable speed drive running at full speed will use marginally more power than that motor will be without that drive, because there's drive electronics inefficiencies. So in this case, unthrottling that valve, right, and then using the drive to limit the flow, to balance the system, $2,200. So again, the operational side of it is so important. So I always like to think about, 4 boxes of opportunities when I think about efficiency, waste and efficiency, and the operating mode is the first one, and then the equipment is the second one. And I put numbers on these things. So I always think, get rid of waste by manual control. Like, my finger actually does a lot of things. I can turn things off, right? Maybe I need to automate that. Maybe I need to put motion sensors, light sensors, whatever. Operating conditions, how well we maintain that equipment. I've got a couple of neat examples in a second. And then replacing the equipment. Because even the most efficient equipment that we could put in will suffer from the poor operating conditions that it might be exposed to. Things like this. And these are real pictures from real energy hunts that we've done, right? So here we see, a condenser with coils that are plugged. Here we see the other side of the system, which is the evaporator within a coil, within a ductwork, and it's plugged quite nicely. Just one second. The reality of a home office, kids, but in my case, dogs, they're very insistent. It would get very noisy if I hadn't let him out of my office. He loves to sit here, but it can get noisy. All right, so now I'm going to take you home, to my home, actually where I am right now. Right, here's an example. I was away for a couple of months one summer, and I had some folks living in my house, and I had left them with strict instructions, change a filter every month, right? And I gave them a stack of filters to do that. Showed them how to do it. They didn't do it. I got home, walked in the basement to unload some stuff from my vehicle. Sure enough, I could hear the fan on low speed circulate making more noise. I know that my furnace, which has an ECM motor, an electronic heat commutator motor, it knows how to speed up when the filter gets dirty. So it speeds up in order to maintain airflow across my heating and my cooling coil. Unfortunately, it's cost me more money. How much? The dirty filter, 353 watts. The clean filter, 111 watts. There's the filters, you can see. That's not that dirty, but it is dirty, right? Did the calculation, right? If I'm running that on low speed circulate, right, during the season that I was, if I left that for another 366 hours, that would be $13. Is it worth replacing that filter? Absolutely. But again, that's a fairly efficient system. But because of the fact that I neglected, or someone neglected, to do some basic maintenance on it, it's using a lot more energy. So just because we put more efficient equipment in doesn't mean we're going to get savings. We still have to pay attention to the basics. Red Screen has all the tools to do efficiency improvement calculations and even doing the capital projects, and it actually has the capital project financial analysis tools in it too, right? So back to the 7 steps and a final step. And the important thing about this step is not the optimized supply or dealing with the supply side, but after waste reduction and efficiency improvement, right? We don't want to, and I always joke that I look out and I see my neighbor that has a solar panel on the roof over there. And I always joke that I would hope that if I ever walked in their house, invited, that I would not see wasteful use of electricity or inefficient use of electricity, because it does not make sense to put solar panels on any building to overcome wasteful and inefficient usage. We need to get the order right. This is the path to net zero. If we reduce our conventional energy use by waste reduction and make it sticky, make it persistent, efficiency improvement, right? Operationally, and then some technologically, and then we can look at things like the heat recovery, the heat pumps, of renewable energy, and maybe even those dual energy systems that optimize for cost and carbon, depending on what the future brings to us. So truly that to me is the way we have to approach this. Jumping, and I'm going to give you an example. My dad, who's a metallurgist, got a lot of respect for him. He taught me so much over the years. He's 92 years old this year, lives in Waterloo. You know, he lost his license a little while ago because he had a stroke. He worked really hard to get his license back because he just bought a new car just before this, got his license back. Actually, it was funny. They didn't even know how to give him his license back. He had to take 4 driving tests at 91 years old. Like, amazing, right? Anyway, he said to me after being driving his car for a couple of weeks after he got it back, he said, Steve, he said, we've missed the boat on hybrids. The world has missed the boat on hybrids. I said, what do you mean? He said, well, we're trying to jump to fully electric tomorrow. Whereas if we had to just jump to hybrids tomorrow and more population, like more of them, we could make a big dent in carbon. And that's exactly correct. And I like to take that now or that principle and apply it to buildings. Let's not try to get to zero carbon tomorrow. Let's take a practical approach, right? Getting rid of much of the waste as possible, making sure we keep that waste out, improving the efficiency of those systems, and then looking for the optimal form of supply to get to net zero. And that can include things like offsets and stuff like that, buying green energy. But there is an optimal solution, and it doesn't start at step 7. It starts at step 5. Waste, efficiency, and then supply. If you want to explore some of the options for things like heat pumps and RETScreen, there's some great modeling tools in there. In fact, this link at the bottom, if you go to that, take a look at some of the resources that are available. So the ISO and Save on Energy now have a program called, or resources called Efficient Electrification. And there's lots of webinars on how to use those tools. In fact, there's one tomorrow. My son's delivering one tomorrow on doing feasibility analysis in RETScreen, all part of their Efficient Electrification support tool. So you can go to that link and have a look at it. Lots of other good things on that site too. A little shelter outside a long-term care home for people to sit and do things. And you needed some light. So how do you get the light there? Well, you could run a cable from the building, right? Then to disconnect and all that. And my friend, the electrician, said to me once, he said, Steve, you know, that's pretty expensive. But what they did in this building was to actually put in a solar panel and a battery and an efficient lamp and a motion and light sensor, provided the light in a fairly efficient fashion, in fact, in a renewable fashion, right? And it turns out that that's probably cheaper than running the wire from the building, right, at the end of the day, right? So waste, efficiency, and supply all wrapped up in one little shelter outside a long-term care home. Just an example we saw in our travels. All right, so how do we apply those 7 steps? Like, how do we do it today? What are we doing today? Well, we probably did 5 or 6 of these in March. We'll do a few more in April. But we call these things treasure hunts. You know, you can call them different things. We do them with CIET. We call them energy efficient building operations. We do them with LAS. We call them operating for energy efficiency. Or there's an Energy Star in the US. They coined the term the treasure hunt. We've created our own version of it. It can be a 1 or 2 day approach, but it's like 2 parts. The first part is an energy workshop. And in that energy workshop, we collect up and we prepare for it by getting lots of data, understanding the building, talking to folks in the building to understand what things they need to understand. So we run the workshop, we engage with folks collaboratively in terms of, the training side of it, but also then in terms of going through the building, right? So we pick a building, we'll walk through the building after looking at the building intensely through its energy data, right? So before we actually go into the building, we look at all that historical energy data, the things that Andrew, you talked about, the interval data, we apply the 7 steps. And we try to become one with the building. I always joke about that, but I know at some point in these things that I've one with the building. I feel that I understand that building, right? And the operators are already one with the building. So the energy guy has to bring, like in these things, we want to bring that energy knowledge together with the intense, incredible amount of operational knowledge that people have in their buildings and find the opportunities. So we do the energy analysis. We do the building walkthrough all collaboratively. We do the building automation system exploration. I do the BAS after we do the walkthrough because we want to see the physical system that's being controlled. Sometimes looking at it through the BAS tends to be a liar at times. It'll tell you this damper is in this position or that position, but when you go out and look at it, it's actually the opposite, right? Or it's not quite what it says. So therein lies some of the opportunities. We come back, we brainstorm, we collect a lot of ideas, and the energy people in the room's job by the end of the day, based on the data and the information provided by the participants, is to come up with a list of opportunities and to put numbers against those opportunities. So it's not just a list of opportunities, it's numbers. And today what we do is we do carbon and energy. I actually don't have a view of one of the outcomes because they're somewhat private, but basically we identify carbon and cost outcomes. to give you an idea of, I've got a couple of examples of units to give you an idea of what we can achieve with these things. But basically, the advantages of the treasure hunt, I'm going to point to one thing here, and that's the engagement, right? Although you'd think you're doing it to get the energy savings, what we're seeing, and we've done do a lot of work with the behavioral aspect, is the engagement of those that participate. If you engage with the folks that are in the building, the persistence or the stickiness of the things that you learn and you can apply is increased. And it does have good payback. I've contrasted on this slide the energy hunt with an energy audit with an existing building commission. We see these things as working together. Oftentimes, either an audit or an EBCX follows our energy hunts. But the energy hunts are a lot cheaper typically than the audits and the EBCXs. And again, they are engaging, right? Significant staff involvement. There are some resources on energy hunts out there. You even have treasure maps, which are really just checklists of opportunities in different kinds of buildings. But there's some formal resources. You can run these things over 2, 3, and 4 days. We do either a 1 or a 2 day version. I think either way works depending on what your circumstance is. Some of the results, just put it purely in numbers. This is about a 250,000 square foot building. Did this in a half a day, right? Half a day treasure hunt. Over $70,000 in savings. There's an example of some treasure hunts that we did. These were ones with the Municipal Association, Oakville, Milton, Halton Hills, Guelph. Significant dollars and significant percentages. I'm remiss in not actually showing. I'm going to go back. Some of you may have seen on LinkedIn the City of Ottawa Better Buildings Initiative. They actually publicized some of the outcomes of the energy hunts we've done over there. And there was one that we hit, I think, 30% carbon, 35% carbon, and about maybe even more on the cost side of it. So these things are delivering significant results. The 7 steps, again, is that path towards net zero. And I know as we're wrapping up here, look at that timing. Andrew, how's that for bang on the numbers, right? So follow up, there is coaching available by myself or others. Andrew and Chris will sending you out this form. So you have access to up to 2 hours per building of someone like myself or others coaching you through how to use RETScreen, or maybe talking about how an energy hunt could be, or maybe Andrew would send us your interval data, your hourly data, and we would analyze that together, right? So lots of things we can do in those 2 hours. Can do a lot of it virtually. Love to give you a hand, but if you have a specific need that goes beyond my skills, we have other experts in our stable of folks that we can direct. So just detail what your requirement is, and from there we'll figure out how to allocate expert resources to your situation. And that is the help desk in any event for today. Over to you, Andrew.
All right, great. Thanks, Steve. Always a pleasure listening and hearing your stories. It's amazing what data can show, and I love that quote from Lord Kelvin about if you can't measure it, you can't improve it, right? So data
exactly.
definitely speaks. And with that, thanks for the reminder about my furnace filter. I did get an EcoBee alert saying that it was time to do it. So
and your fridge condenser. Work hard to clean that fridge condenser. If you can get to it, get the dust off it. That'll pay back no time. It's also good in the spousal relationships too, right? Because you're cleaning the kitchen.
So another takeaway here too is to unplug my microwave time clock. So I mean, I got the stove one right below it too. So I don't.
How many clocks do you need, right?
How many clocks do you need too? Yeah, right. And I remember, I think you told a story too about 2 comparable buildings. One had like the latest, greatest state-of-the-art technology, and the other one had a really, really good operator that just knew that building in and out. And you did a comparison between 2 buildings, and it was the one that had the operator that was hands-on and knew it inside out, that was the one that was more efficient, even though the other building had the latest.
It was a rink. Yeah, it was a rink. The BAS system had gone on the fritz, and basically it turned out that the operator without any BAS was actually able to operate the building better than any of the other rinks in the city. So that was pretty amazing. Actually, I have an example from one of our energy hunts that we did originally. I'm just going to pop it up here on the screen. Hopefully it'll come up just before you grab the screen back, just to show you. So this is one that we did. Here we go. This is what we did in Toronto. This was part of the Green Will initiative with the City of Toronto. And we did this one with SEAT. and it was on the life sciences building at York University. So look at this. This is a relatively new building. There's the measures, and 21% cost reduction, 29% emission reductions. And what we like to do, we do these hunts, is to produce this kind of a graphic at the end of it that really just sort of, in a nutshell, summarizes what we found. And that 21% was $122,000 a year in financial benefit. So, all right, back to you.
All right. Well, I think I only have one more screen to show here, and that is our question screen. So a lot to digest there, I think, from everybody. Is there any pressing questions, any follow-up that you want to ask? We will send out, as Steve mentioned, the resources as well as a copy of this presentation, and the recording we'll put on our website if you need to watch it again. But yeah, fire away. Any questions? We have a few minutes. Like Steve, he's right on the button here, which is great. So, all right. If no questions, then I say, you know, I hate to say it, but I'll give you 5 minutes back. But
Oh, that's good.
well, thank you for giving us your time today. Really appreciate you joining us and listening. And like I said, we have some upcoming webinars of some cool topics. So we hope you can tune into that one. Keep an eye on your inbox for the invitation. And with that, everyone have a great day.
All right. Thank you, everyone, for joining
Thanks,
us.
guys. Yeah.
Thank you.
Thanks all. It was a good presentation. Well done.
Thank you.
Thank you, Paul.
So long. Yeah.